Swayam Prabha. Digital India. Educated India.
Welcome back. So, in our last lecture we have shown that how the total product curve looks like and how using a 4 quadrant diagram we can uniquely derive total cost curve given a total product curve, right. So, this total product curve or total cost curve, see when we are introducing total product curve is telling what? That is giving or that is a reflection of the technology we are using in our production activity, right. The how much variable input you are using and for by use of that much variable input how much total output you are getting, right. So, that is the thing. So, now sometimes we have shown so far whatever total product curve that looks like say this kind of thing continuously converge. So, we are measuring variable input in the horizontal axis, variable input, okay, and vertical axis output quantity, output this side variable input quantity, right, and this kind of total product curve we got. And we have shown that if this is the total product curve, this is sometimes called production function also, production function, okay. Production function means what? It is a functional relationship. Suppose output we are denoted output as say y and variable input say as x. So, we can have say y equals to some function of x, that function captures this relationship, right. So, that is why it is sometimes called production function, because there is a functional relationship exists between variable input and output what we are measuring in that 2 axis in this diagram, right. So, this is our total product curve, and using the 4 quadrant diagram we have shown that how the total cost curve can be uniquely derived from this kind of technology. This total product curve, as I told, that it is a one sort of reflection of the technology, reflection of the knowledge level, know-how, technical know-how what we are using to produce this commodity using this input, right, and maybe some other fixed inputs are there which are in the under the ceteris paribus condition. So, we are keeping those inputs at some given level, and it is just one variable input vis-a-vis one output, that relationship is captured by this total product curve, right. And so, in that case uniquely derived from this kind of technology, uniquely derived total cost curve will be say we are measuring total cost here on the vertical axis, and horizontal axis we are measuring output. Be very careful, any cost curve, total cost curve, average cost curve, average variable cost curve or marginal cost curve, whatever different cost curves we will draw, horizontal axis we will measure always output, okay, output only, okay. So, in that case we will have this kind of total cost curve, right, we have shown, and this is short run total cost curve as we told, because this is the total fixed cost. So, this horizontal line we can tell total fixed cost curve, and a parallel of this kind of convex line say this kind of we can tell total variable cost. So, if I add for every output level this plus this will be this much and so on, this plus this will be this much and so on, right. So, this is total variable cost curve, this is total fixed cost curve. Since total fixed cost is fixed and it does not vary with the output quantity. So, whenever output is this much, whatever the total fixed cost, at this much output same amount of total fixed cost, this much output same amount of total fixed cost, that is why it is a horizontal line, total fixed cost line. And so, if you add total fixed cost plus total variable cost, you will get total cost, this kind of thing. So, we have shown how we can uniquely derive total cost curve given the technology represented by this total product curve, right, okay, using the 4 quadrant diagram in the. So, we will introduce today that another looking of total product curve. Sometimes total product curve can be this kind, say as usual you are measuring variable input in the horizontal axis and output in the vertical axis, and your total product curve may be this kind. This is the total product curve, okay, or production function what we told in the earlier diagram. Okay. When this kind of total product curve is coming, say look at here, when we told that this is the total product curve, okay, marginal product of every additional unit, right, it is always falling, it is a globally concave curve. So, it is always falling. Not only that, average product how we define output per unit of variable input, right. So, average product is also continuously falling, right, because average product will be the slope of this ray through the origin, right. At this particular point average product is slope of this line, at this particular point average product is slope of this line, and so on. So, average product is continuously falling. But in this kind of, instead of, if this is the total product curve, look at here, marginal product at this point slope of this tangent, at this point slope of this tangent, at this point slope of this tangent, at this point this. So, look at here, marginal product is increasing until a point, and after that it is falling. Okay. And exactly the same way, if you draw average product at this point, it will be slope of this line, at this point slope of this line, this point slope of this line, and so on, at this point slope of this line. When in that way it is going, at this point it is slope of this line. So, average product also is increasing up to a point and then it is falling, right. So, let us try to understand when this kind of total product curve can come. Look at here, in this total product curve we are measuring horizontal axis, we are trying to capture the relationship between variable input, one variable input which is measured in the horizontal axis vis-a-vis total amount of output what is measured in the vertical axis, right. So, of course, whatever other factors are there, those are under the ceteris paribus condition. So, those factors, their quantities kept at some given level, right. So, it can happen that for first few, as you are say at this point your amount of variable input employment 0, as you are starting this employment of variable input increasing from 0 to here, here to here, and so on, it may happen that initially the rate at which you are expanding your variable input, output is expanding much more faster rate. That is why for a initial stage your total product curve can have this kind of segment, okay. But eventually after a threshold or after a point it will fall, okay. This kind of as marginal product is falling, no, it is called diminishing marginal product. Marginal product is falling for the subsequent or for the additional unit of the variable input, right. So, since marginal product is falling, it is called diminishing marginal product, law of diminishing marginal product, okay. And in this kind of thing, when this is your total product curve, so here after this point this is law of diminishing marginal product is applicable, right, because marginal product after that point marginal product is falling, okay. But before that marginal product was increasing, okay. So, not only this segment marginal product is increasing, also average variable average product also is increasing. Under which condition that can happen, what I told, right, it may happen that as you are hiring that your variable factor which is measured in the horizontal axis, okay, the rate at which you are increasing use of that factor, okay, your output may expand much more faster rate. Let us give an example when it can happen, okay. See, there is a classic example by Adam Smith we have heard, right, he is called father of economics, okay, and he only give term this market as invisible hand, if you can remember. So, Adam Smith has given one beautiful example of division of labor regarding pin production, okay, pin production, okay. So, how division of labor can make you get output to expand much more faster rate vis-a-vis as you are hiring more and more labor. So, let me give you that story. Say suppose you are hired this room, okay, and you are going to establish your pin production workshop in this room, right. So, pin, to produce pin, no, it is a metal thing, no, small metal kind of instrument, right, pin. So, to that what is your ingredient? Your ingredient is basically metal wire, okay, and usually metal wire are available in the market in roll kind of thing, okay, rolled. So, suppose when you hire only one labor, what will happen? That labor, he has to do the entire all the activities attached with that pin production. What are those activities? Okay, you purchase from market that metal wire, rolled kind of metal wire. First you have to straighten that metal wire, right, it make to be first straightened, then you have to cut some specific size, you have to cut, right, in this much pieces, okay. Then whatever the cut pieces of that wire is coming, one side, this kind of wires are there, right. So, one end of that wire needs to be sharpened, okay, and another end there should be a cap, metal cap, right, then pin will be produced, right. So, you hired only one labor. So, that labor first he is doing, first he is stretching, okay, straightening the rolled kind of metal wire what you purchase from the market, then he is cutting those things into this kind of specific sized specific length kind of pieces, okay. Then he is doing one end of those pieces, no, sharpen, then he is doing another end, he is putting that cap one by one to each pin, right. Now, suppose when you are hiring 2 labor instead of 1 labor or 3 labor, right, what you can do? You can engage into division of labor. By that what we are referring means you are segregating labors into certain groups, okay. Maybe one person will only stretchen the rolled metal wire, another person will only cut, okay. Another person will only sharpen that one end of that cut wires, and 2 person they are sitting at the end, they are just putting the cap, because putting cap, no, it may take little bit more time, right. So, you are hiring until 5 labor, it will be very easy, because productivity of the labor at each stage of this production will be much more than when entire works was performed by only one labor, because one person only he is stretching rolled thing, only he is stretching, another person only cutting, okay, and not doing any other work, another person only sharpening one end, like that. So, they are involved into only one type of work, as a result they could do that work much more faster rate, right. So, as a result, so within the, if this is the way I explain the division of labor, say until 5 laborer. So, as you are increasing more and more higher from 0 labor to 1 labor, 2 labor, 3 labor and all, you will see that output per unit of labor it is increasing, because you are doing some division of labor among themselves, right. See, I am sure many of you have watched that classic movie by that Charlie Chaplin's movie called Modern Times. I am sure many of you have watched that movie. So, you will see that in the factory, no, that Charlie Chaplin and 2 other workers, no, that there is a long movable kind of tape is there, and on that tape that nut bolt were there, right. So, 3 workers they are only just tightening that nuts, okay, only they are doing that work, right. So, you can imagine how much faster they can do eventually, that movie it is shown, how much faster they are doing that. It has some negative implication on those particular people, they have to be, because it is a monotonous work, no, they are becoming that kind of thing, right. So, that is to make that funny thing into the movie's story, right. But the basic message is that one person is concentrating on different segment of the work, vis-a-vis one person only concentrating on a specific segment of work. The rate at which your production will increase when you are doing this kind of division of labor, okay, production will increase much more faster rate, okay. So, due to perhaps division of labor and similar kinds of other things, right, you can have a total product curve this kind of thing, until initially total product curve have a convex kind of shape, and eventually due to law of diminishing marginal product, eventually after a threshold level, after a point, it is becoming concave. Okay. So, that kind of, so if we have that kind of total product curve, okay, so we can easily see that what kind of total cost curve will be that time. So, if your total product curve, when you are measuring say variable input say x in the horizontal axis and output y in the vertical axis, if your total product curve is this kind, okay, your total cost curve, of course, you are measuring output in the horizontal axis and total cost in the vertical axis. So, your total cost curve will be this kind, okay, and definitely it is a short run total cost curve, right. This is total cost, this is total product curve, right. So, this will be short run total cost curve because this is the, so this may be the total fixed cost line, okay, and maybe total variable cost curve looks like this, right. And if this is the total product curve, this will be the total cost curve, short run total cost curve. No, you can easily see using the same strategy what we have used that 4 quadrant diagram, right. You can do that. So, using this thing we will now show whatever relationship or what kind of relationship may exist, say when your total cost curve this kind, right. You see that marginal cost at this point is slope of this tangent, marginal cost curve, marginal cost at this point slope of this thing. So, marginal cost at this point slope of this thing, marginal cost at that point slope of that thing, and so on, right. So, as you see that as output is increasing, why you are measuring horizontal axis and this side total cost curve, total cost, right. So, as you are increasing your output, marginal cost is continuously increasing because this tangential points, tangents, no, they are becoming steeper and steeper, right. So, as if we have a continuously rising marginal cost curve kind of thing, right. But if this is the total cost curve, at this point what will the marginal cost? Slope of this line, this tangent. At this point what is the marginal cost? Slope of that tangent. At this point slope of that tangent. So, at this point slope, at this point slope of that tangent, at this point slope of that tangent. So, you will see that first marginal cost is falling within this segment and then it is increasing. So, as a marginal cost curve is an U shape kind of thing, right. So, in economics we usually discuss using typical U shape marginal cost curve, okay. So, in this particular case it is upward rising, continuously upward rising marginal cost curve. So, this kind of total product curve if it is, you have this kind of total cost curve you have, you can derive that uniquely, okay. And if this kind of total cost curve you have, you can have an U shape marginal cost curve, right. So, now we will, so we have defined in the last class that what is the definition of marginal cost, what is the definition of average variable cost, what is the definition of average total cost, all those things we have defined, right, and average fixed cost. We have also introduced that average fixed cost curve is a rectangular hyperbola, right, because horizontal axis you are measuring output and vertical axis you are measuring average fixed cost, okay. So, their product is always constant, total amount of fixed cost. So, that is why it is a rectangular hyperbola. Let us try to understand what kind of relationship will be there between average variable cost, average total cost and marginal cost, okay. So, that we have shown in a diagram at the end of the last lecture, okay, that we will prove today, okay, that marginal cost curve should cut average variable cost and average total cost both of their respective lowest point from below. So, let us try to prove that, okay. Okay. So, total cost, how much total cost go to the other, say different total cost at this point this is the total cost, at this point this is the total cost, at this point this is the total cost. So, these different points how they are changing due to different values of output level. So, I can tell or we can tell that total cost is a function of output because that depends on if output level is this is the total cost, if output level is this is the total cost, okay. Total fixed cost we can't claim that it is a function of output because it is fixed cost, it remains fixed, whatever amount of output you are producing fixed cost will be the same, okay. But total variable cost and total cost, okay, all will be as a function of output only, right, amount of output, how what you are producing, accordingly your total variable cost is determined, and hence according to that your total cost also is determined, right. So, we can tell that total cost is a function of output, that is total variable cost which is also a function of output plus total fixed cost which does not depend on output, right. Now, total variable cost, right, total variable cost I can write average variable cost as a function of output into output, because how we have defined average variable cost, it is basically total variable cost by amount of output, per unit of output how much total variable cost the producer is incurring, that is the average variable cost, right, that we have defined. So, this total variable cost I am writing output into average variable cost, of course, it will be a function of output plus total fixed cost, right. Now, if I take the derivative with respect to output of the both side of this equation, okay. So, marginal cost how we have defined, marginal cost is basically change in total cost due to change in output, right. So, basically del total cost as a function of output by del y, if we take, that will be marginal cost, okay, change in, so marginal cost, right. So, it is a derivative of the output in the calculus notation, derivative of the total cost due to with respect to the change in output, right. So, if I take the derivative in the both side with respect to y, so it will be left hand side, it will be del T c as a function of y del y, that will be del y, the third bracket y into AVC y, okay, plus TFC, right, that. So, this left hand side is basically marginal cost as a function of output. Right hand side, look at here, this component when I am taking del y into y into AVC, average variable cost, average variable cost is denoted by AVC, okay, TFC total fixed cost, total cost, okay, AVC as a function of y, this plus del, since total fixed cost is fixed and it does not depend on y, definitely that derivative will be 0. So, del y of TFC, this will land. So, this first component will be what? This will be AVC as a function of output into del y 1 plus y into del AVC del y, AVC as a function of output, this plus 0, this component will be 0, okay. So, this 0 I am erasing. So, this is the thing, right. So, what we are getting, marginal cost is basically average variable cost whatever it is plus y into change or the derivative of average variable cost curve with respect to output. Now, if we plot that in a diagram, suppose we want to measure marginal cost, average variable cost both in the vertical axis and output in the horizontal axis. Look at here, this relationship what we have derived, okay. This relationship is basically when y equals to 0, that time when y equals to 0, that time this component is 0, that time marginal cost and average variable cost curve are same, value are same. So, when y equals to 0, average variable cost and marginal cost both should start from the same point, because that same vertical, same point on the vertical axis means for the when y equals to 0 what is their value, okay. Not only that, when this component is 0, that time also these two are same, right, because y into that equals to 0. So, this together. So, if average variable cost curve is basically an U shaped line, look at here, okay. This is your total variable cost curve. So, average variable cost will be what? At this point slope of this, at this point slope of this line, at this point slope of that line, at this point slope of that line, at this point slope of that line, and then at this point slope of that line. So, it is falling and then start increasing like. So, it is basically if you measure y output in the horizontal axis and vertical axis the average variable cost, it will be an U shape kind of diagram, right. So, exactly that we are plotting here. Okay. So, suppose this is your average variable cost curve, okay, and definitely where it is its lowest point, where it is attending that point del AVC, this is the AVC curve as a function of output. Look at output we are measuring in the horizontal axis. So, del AVC as a function of output by del y, that will be 0 at its this point, where that AVC U shaped at we are attending the lowest point. Okay. So, at this point AVC and MC value are same, at this point AVC and MC value are same. So, at point A and point B ABC and MC value are same. Okay. Now, so this segment of AVC, when AVC curve A to B that segment, okay, AVC curve slope is what? Negative, no, it is downward sloping. So, negative. So, when this is negative, this value is negative, y to in any case positive. So, this y into this negative value, this is negative, right. So, MC will be whatever the AVC value that minus something. So, so long AVC has a negative slope, that time MC will be below the AVC, because AVC value minus something, right. So, so long, so for this segment, downward sloping segment of the AVC curve in our diagram AB segment, okay, it is basically MC will be below the AVC curve. So, MC curve will be this kind, at this point it will be same. Now, look at here for this segment which is upward rising segment, right hand side upward rising segment of AVC, that segment this thing is positive, y to in any case some positive. So, positive into positive equals to this entire thing will be some positive for this segment. So, for this segment when AVC has a positive slope, for that segment MC is whatever AVC value that plus something. So, definitely MC value will be above the AVC, MC will be larger than AVC because it will be AVC plus something, right. So, MC curve will be this kind. So, what we are getting from the same vertical axis, MC and AVC curve are starting, this is the AVC curve, okay, and this is the MC curve, it is both are U shaped. So, MC curve is cutting AVC curve at its lowest point from below, okay. This is I hope understood to everybody. So, exactly the same way if we have an AC curve, okay, whatever the relationship it will be. So, let us say total cost as a function of output is total variable cost as a function of output, okay, not total variable cost. I am writing total cost is basically y into average cost as a function of output. This average cost means average total cost, okay. So, if I take derivative from both sides, so left hand side it will be MC as a function of output, okay, this will be y, this will be AC as a function of output plus y into del AC del y, okay. So, exactly same sort of relationship what was there between MC and AVC, exactly same sort of relationship MC and AC we will get. So, if we plot all those things, okay, all those three, both average cost or average total cost, average variable cost and marginal cost, all we are measuring vertical axis and output we are measuring in the horizontal axis. So, we will have three different cost curves, right. So, we will have one AC curve, it is an U shape, okay, one AVC curve, okay, and one MC curve. this MC curve is cutting AVC curve at its lowest point, AC curve also at its lowest point. Look at here, exactly the same way we can prove that, okay, when this segment is negative, right, that time MC will be below AC, that time MC is below AC for this segment, that segment is negative. And for this segment, when this part is positive, that time MC will be above AC, MC is above AC for that. So, it is going above, right, and at this particular, when this is equals to 0, that means when it is at the lowest point of the AC, okay, that time this is 0, that time MC and AVC are same. So, it is cutting here. Okay. So, this is the relationship between average total cost, average variable cost and MC. One more clarity, look at here the way I have drawn average cost and average variable cost curve are coming closer and closer as y is increasing. Why? Because average cost minus average variable cost, it is basically average fixed cost. Why? Because total cost equals to total variable cost plus total fixed cost. So, if I take both sides, if I divide by output, this is basically average total cost is basically average variable cost plus average fixed cost. So, average fixed cost is average cost minus average variable cost, right, this we are landing. So, since average fixed cost will continuously falling as y is increasing, rectangular hyperbola. So, as y is increasing, this gap between average cost and average variable cost curve will be closer and closer. So, they will be closer and closer, right. This is the thing. Okay. This is average variable cost curve. Let us stop here, and now we will discuss in the next lecture, we will discuss that how long run total cost curve, average cost curve, marginal cost curve, how they look like. Okay. Let us stop here.